So when you look at B, does anyone feel like they might have got it? Okay, what'd you do, Isaiah?
I made an integral multiplied by 3 of from 0 to 30 when I put the equation in.
Yeah, that's good.
Really?
Yeah.
Oh.
Yeah. So because this is representing the depth, and that's the area of the base. The millions, these, whatever outputs you get from this is in terms of millions, because they tell you that this is millions per cubic meter. So you don't have to do anything to your answer. It's already in terms of millions.
And it's already squared. You don't
Yeah.
have to do
Yeah. So that was exactly right. Yeah. Okay. So the subtle part between B and C is that this is only considering that column from 0 to 30, and that the problem says anything that's above 30 has this other equation, f of h, which is continuous, but other than that, we don't know anything about it. Okay? And then down in part C, they give you like this whole mess that's kind of hard to interpret. Okay? So if you look at this, we know this, and when you look at this, what does this kind of remind you of?
The series.
Series and what else? Like it reminds you of a little bit probably of the limit comparison tests or direct comparison test. What about things that we dealt with like way earlier in Calc AB? They're theorems. Not fundamental theorem. We talk about them with 3 letters. MVT and IVT. That's what it kind of reminded me of. And if you have that line of thinking, you're thinking correctly, that if you can kind of prove that one of them is like the biggest, then the other one must be in the middle, if that makes sense. So you're using the inequalities to say if I can prove one part of the inequality, then I can assume the other part of the inequality that I can't prove, I can assume that's going to do the same thing. Okay? So you're going to have to do something with this inequality. This is where you're going to start, like your argument is going to be with this inequality. But they gave you this right here, that the integral from 30 to infinity is 105, right? Now that's just the height, right? That's not taking the area of the base into account. That's just the height. And that's only the height from 30 to infinity. That's not keeping in mind the part that we just found in answer B that's 0 to 30. Okay? All right. So they're giving you an idea. Now the nice thing about this is they're telling you that your answer has to be less than or equal to 2,000 million, which means that once you get to the answer, you're probably going to know you got to the answer, because you're going to get something that's less than 2,000 million, okay? So here's how we're going to think about this. They said that K is greater than 30, it's some number greater than 30, and because we know how numbers work, K is going to be less than infinity because that's the biggest possible number we can have, right? So we're going to think about if I can look at this problem right here, the u of h, and I know the integral from 30 to infinity of u of h is 105, if I can think about the part of the column I already have and I can think about this part correctly, then I'll know what my biggest number possible could be. And then since this inequality tells me that f of h is smaller than that, then by default f of h has to be smaller, okay? I think this problem is kind of okay to find the answer to, but writing it mathematically in a way that will get points for this problem is a little bit harder, okay? So when you include your reasoning on this, you're going to have to include an inequality that you have adjusted from this one that has some integrals in it, okay? So you're keeping this in mind. This is the lower part of the column. This is the upper part of the column, and that's going to tell you what your very biggest volume, basically, what your very biggest could be. And then you're going to know, you just have to prove that this has to be smaller than that, and you're going to do it using an inequality. Okay? Those are my hints. See what you can do with it, okay? Yeah.
So can you explain how we got that to figure out that the integral of the u of h gives
The volume is area of the base times the height. And in this problem, so we're thinking of like a column, which is like a 3D shape, which is why I'm kind of thinking volume of like what would fit into that. They tell you that the area of the base is 3 square meters, that that's a constant. And then the height would be like the depth that you're going. And the depth is being modeled by this equation. And so integrals are how we kind of add that height together. So think of it like the problems where you have the cross sections and you were taking slices and adding them together. So it's like you have slices that have an area of 3, and you're basically adding up the chips in a Pringles can to find the volume in a Pringles can, is essentially what you're doing. So you have a slice plus another slice plus another slice. You have infinitely many slices going from 0 to 30. And the height is kind of what's changing here. And so that's why we're using the integral. We're using calculus because it's not a constant. So we can't say a constant area of a base times a constant height. The height is changing for each of those areas of the base.
Can you explain again how the integral represents?
Well, integrals, remember, so it's kind of like saying when we did the problems where we were doing volume by cross-section, and we found like the different shapes of the cross sections. This represents the fact that we have infinitely many. It's kind of like we're getting those smaller and smaller and smaller and smaller slices of different heights of like a rectangle or some sort of shape. And the area of that shape is 3. And then these are all our different slices that we're adding together. I'll see if I can come up with another way to phrase it, but that's anytime you have repeated addition, that's when you're using an integral. And specifically when you have repeated addition with something that can be changing like that. Because if it was the same, we would just use the normal formula for volume. But since we have heights that are changing, that's what makes us have to use calculus. Yeah. So this integral is just saying that we're taking all these different parts of maybe from 0 to 1 has one height, and then 1 to 2 has another height, and then 2 to 3 has another height. So we're taking the same area of the base, but we're multiplying it by different heights. And that's what the integral is representing, is that we're doing all those different heights. Does that help a little bit? Yeah.
I remember learning about this. I think I just need some time to.
Yeah, it feels more abstract when you don't have like a picture to go with it, for sure. I mean, yeah, you can graph it and then just think about like the function, the y coordinate of the function is basically the height. And then you just always know that the area of the base would be a 3. So if you're thinking like area of the base times the height, yeah. Okay, go ahead and see what you can do with that one. So p prime of 25, that's a calculator question. And fairly easily you should have got the negative 1.179, right? Okay. Then the weird part is the interpretation using those units. So your y value was millions of cells per cubic meter. Your x was meters. Okay, so if we interpret this in a sentence, we're going to say at a depth of 25 meters, the density of the plankton cells is decreasing because it's negative by 1.179 millions of cells per cubic meter per meter. All right? Weird units, but that's how it should be. Okay, so I've got, there's my y, there's my x. All right, part B. So we have 3 times the integral from 0 to 30, p of h times dh, which is 1,675.415 million. They said round to the nearest million, so it's 1,675 million. Okay, here's how I started off my thinking for part C. I said, if I want to calculate that column using something that was more than a depth of 30, then I would say 3, that's my area of my base. And then my height would be 0 to 30 for the p of h function, and then 30 to k for the f of h function. That's how I would be like calculating that entire column. So everything from 0 to 30, anything above 30. Okay, so then what I did is I said, let me think about it the same way, but I'm going to use my u of h instead of f of h because I want to figure out what like the biggest possible thing could be. So here I said 3, and then I said 0 to 30, and then I said 30 to k, But I was thinking, what if I have the limit as k goes to infinity? Yeah.
Did you have to write a limit like that? Or...
Sorry, this is not a good time. Are you bringing me nice little notes, though?
Yeah.
You can come drop them on my table. And then I have to teach. I'm sorry. I'm sorry. Thank you. Thank you. Appreciate it. Bye, guys. Bye, guys.
Read them in order.
Okay, I will. Number 1. Got it. All right. So you do not have to write the limit. You just know that k is a smaller value than infinity. I'm just leaving this because this is how I really wrote the problem, like when I did it before I looked at the rubric. Okay? So
write an infinity in their integral. Are you not supposed to do that?
they will. I'll explain it in a second. Okay? So if you think about this kind of like with that infinity in there, if you evaluate this just like it is, so I have the 3. If you do from 0 to 30 of that p of h, you get this decimal right here, which is what you would have used, that 3 times that is that 1675 number we got. And then the other one, this one, if we do 30 to infinity, it's 105, right? And that was from the problem. They gave that to us. And if I multiply that, that's 1,990 million. That's the part where I feel better because I know that's less than 2,000 million. Does that make sense? Okay. That is where I stopped. I didn't really know what to do with that. I knew that I had that right. I just didn't really know how I needed to write it. I knew it probably had to do with the inequality, but then I was just like, I'm done. I'm going to look at the answer and see what it is. So from here, this is what the rubric wanted you to have. This inequality, right? Since we have 0 is less than f of h is less than u of h, then we can say that 3 times the integral from 30 to k of f of h is supposed to be less than 3 times the integral of 30 to k of u of h, right? Because k is going to be smaller than infinity, which is less than or equal to 3 times the integral from 30 to infinity of u of h. And because of that reasoning, you can say, yes, like what they were saying is true. But the math behind it is this math right here. And then this is us using an integral to like be mathematically correct, you know, and formal about showing our answer. Okay? Yeah.
I think I might have gotten lucky on this one because I got the same answer, but all I did was the 0 from 0 to 30. I had that answer from B. And then I added 105 times
3. You did the same thing I did. Yeah.
Okay.
You did the same thing I did. You probably just wrote it differently.
Yeah.
But you did the same thing. You said the column already has this, so let me add the top piece, and the top piece is 3 times 105. But that 3 times 105 is not the actual answer because they're talking about u of h, and the problem referenced f of h. U of h is the idea of like this is it's too big. It's like bigger than the actual answer should be, and so you're fine. But your math is exactly right of thinking of the original from 0 to 30, that part of the column, and then adding something on top. Yeah.
So what I wanted to get something, I'm not sure if I got it, because it's like, well, it's close. But what I wrote was some integrals, but I didn't use the k. I just said like what if it went to infinity, which would be the largest value.
Right.
So I basically wrote similar inequalities, except I didn't write a k.
Okay.
And then
you had an infinity here.
Yeah.
And then you had just 0 on one end.
So yeah, I had a 0.
Okay.
And then it was 0.
So this would be a question we really probably would have to go back and look at student responses and compare it with the rubric and really see like how different people would have written this one, because I think this is a problem where people may have not as clearly gotten the right answer, if that makes sense. So I'd be curious to see what the rubric says and what the... Okay. And then part D was a pretty simple one. So they gave you the x prime and the y prime. And so we know that the distance formula is just the square root of x prime squared plus y prime squared. So as long as you could type it in okay, you'd get the points on that one. All right, so I did not print the rubrics. I can do that now real fast and bring them back. Or if you guys want to look it up on your phones, you can do that. What would you prefer? Print them? Okay, so give you some hints. Okay, so for this one, they gave you the function. They want you to find the slope of the tangent line. I think we can do that. We want to find the x-coordinate of each critical point and then classify it as a relative minimum, a relative maximum, or neither. We know what to do for that, right? Yeah? Here, they said that we can use this identity that they did the partial fraction decomposition for you. Are you seeing that? Okay, I have a hint for you here because you can see this, right? You have to integrate it and you have that from 5 to infinity. So this is an improper integral. So when you evaluate an improper integral, you have to be careful of your notation because we cannot, on an FRQ, we cannot plug infinity in and evaluate it. That would not get us points because you can't plug infinity in, it's not a number, all right? So you have to be careful that when you're evaluating this that you are writing limits. The other thing you have to be careful of is to remember your properties of logs. Because if you don't think of your properties of logs, you're going to get one answer, and if you use your properties of logs, you're going to get another answer. Okay, so those are my two hints. First hint is to make sure that you're careful when you evaluate the infinity, 5 to infinity, so make sure you write limits when you do that. My second hint is to use properties of logs. Okay, and then from C to D, D is talking about series, but and we haven't reviewed that yet, but I think that it was recent enough that you'll probably be okay with this one. Your conclusion for C is going to make D a really easy answer. Be really careful. I would say underline this part. State the conditions of the test that you're using. So there was continuous, decreasing, and positive. Positive, continuous, and decreasing. And you're going to specify that it's that on a specific interval. Okay? All right, so those are my hints. I will go print those rubrics for you. All right, so for part A, you needed to find the derivative so that you could evaluate it at 3. And I just did the quotient rule, and I ended up getting that my slope was negative 15/4, which is good. To check for critical points, I'm always wondering when they want critical points in FRQs if they want you to set it equal to 0 or see where it's undefined or both. So I went ahead and set it equal to 0 first and I got 7/4. And then just to be careful, I checked to see where it was undefined. And that was actually 1 and 2.5, which was like, oh, that's probably why they chose those values. So then I went ahead and I did my sign chart and I saw it was positive and negative. And so that told me it was a relative max. And a sign chart does not work for being like your reason why. You have to explain. And so I said it's a relative max. And you could say because it switches from positive to negative, the signs do. You can't just say it switches signs because that doesn't tell you a max versus a min. You have to specifically say from positive to negative. So I wrote the derivative is positive and then the derivative is negative. And I gave the intervals, but you don't have to say that exactly. You could just say it switches from positive to negative. For part C. All right, so for this one, I went ahead and I separated my integrals because I knew that this one needed u substitution. And so I went ahead and I did the u substitution, and then I had my ln of 2x minus 5. And then over here, this was ln of x minus 1. And because this is a minus, you have your properties of logs where you can say ln of 2x minus 5 over x minus 1. And that was important. If you didn't do that, you weren't going to get it right. Okay. You do technically need your limit notation here because you're evaluating it for infinity. So instead of saying from 5 to infinity, I said from 5 to k, or you could say 5 to another letter. You just really shouldn't say 5 to infinity because we can't plug infinity in. Okay. So then over here, I did the same thing. So limit 5 to k. Now, if you think about this, the limit as x goes to infinity, since these, the negative 5 and the negative 1 don't make a difference because when you think about plugging in infinity, they're so small that they are not necessary to have there. And then 2x over 1x would just be 2. So that's where I got the ln 2 from. And then for the other one, I have 2 times 5 minus 5 over 5 minus 1. So you could have left it here, ln 2 minus ln of, you actually could probably have left it here to get credit. But if you simplify it all the way, it's ln of 8/5 is what the final answer is. You should be able to do just this part and get credit. So just plugging all the numbers in. All right. And then for part D, you do have to say that this is your function. Your function is positive, continuous, and decreasing on that interval. And then once you can say that, you could say by the integral test, the integral has a numeric value. It's not infinity or anything, and so that means it converges. So that conclusion was pretty quick. You could also use one of the comparison tests, which is on the rubric, and I'll hand that out so you guys can check that. Okay. We are not going to do the other FRQ because we obviously don't have time. So I'm just going to leave that. But I will go ahead and put up the student responses for that